This question says, when we have a certain string that's clamped at both ends, the four lowest resonant frequencies are 50, 100, 150, and 200 hertz. When the string is also clamped at its midpoint, then the four lowest frequencies, resonant frequencies, are what? Well, let's draw this out. So if I have a length, my four lowest ones, I'm going to have the string that'll look, should draw the second one just so we can see what the pattern looks like. I have the four lowest resonant frequencies to be 50 hertz, 100 hertz, 150 hertz, and 200 hertz. So hopefully this is what your picture looked like. So the string is going to oscillate up and down. It's going to do a back and forth motion between these. String will do these four lowest ones. So now what happens if we were to clamp it at the middle? We pinch down at the middle point in each of these cases. Well, notice that if we pinch this one right here, that our wave can no longer exist. If we pinch it in the middle, well, this one doesn't exist. If we pinch this one in the middle, it looks like we're at an n equal 1. So if I were to look at the half wavelength, I know that I'm going to get the four lowest ones to be the same things that I got before, but on a smaller scale. So this is n equal 1, this is n equal 2. But this length right here is equal to one of those over here. This one right here is equal to those guys. So we're seeing that the lowest frequencies that we're getting are 100 hertz, 200 hertz. We can imagine that the next one we're going to get looks like this, which would be n equal 3 over here, but it would correspond to n equals 6 for these guys. So the odd number ones, when we go to half the length, the odd number ones no longer can exist because they have to have an antinode at the middle. Us putting our finger down would force a node at that place, so it can't exist. So C is going to be our right answer. 100, 200, 300, 400 will be the four lowest ones. Let's see how this works out if we actually look at the equation that we get. So f of n is equal to n over 2l square root of t over mu. This is the standing wave on a string, what frequency it happens at. If we have a number of antinodes, the length of the string, the tension, the mu. And we're going to assume that the tension, mu are going to be the same, and we're going to look for n1 through 4. So the frequency that we get over here is n over 2, L over 2, because we substitute in our length being half the length, which is equal to n over 2L, square root of t over mu, and we have a 1/2 out in front. And if we notice something, we'll notice that this piece right here is equal to f of n. And I actually made a mistake. It should be 1 over 1/2, right? I get a 1 over 1/2, which means this is equal to my original, prime this one, this is equal to my f of n times 2. That's f of n, and this is 1/2, or 1 over 1/2, which gives me a value of 2, which means all of my frequencies for the same n, the same l, or for the same n, the same t, and the same mu, and doubling l, or halving l, will give me twice the frequencies, which what I got up here.